Welcome to Chapter 1, Lesson 1, Rational Numbers. Our objective or learning target for this lesson is to write rational numbers as decimals and decimals as fractions. As you'll notice, the CCSS, that is our Common Core State Standard, is 8.NS1 for this lesson. Let's get into some vocabulary. First, rational number. A rational number is numbers that can be written as a comparison of two integers expressed as a fraction. As you will learn through the videos, you may pause your video and write down the definition and then hit play as you finish your definitions. We're going to look at some examples on our next slide of rational numbers. Our next vocab word, repeating decimal. A number or group of numbers that go on forever. Don't worry about the. I don't know how that got in there, but we'll make sure that gets out. And our last vocab for this first lesson is terminating decimal. If the repeating digit is 0, then the decimal stops. As I said, we'll get into some examples of these in the next couple slides. Moving on. Our key concept. Our key concept for this lesson is rational numbers. Put into words, a rational number is a number that can be written as the ratio of two integers in which the denominator is not 0. Symbols. We're talking about a ratio. A ratio can be A over B, where A and B are integers, and B is not equal to 0. And our model right there, as you see in the middle, is natural or counting numbers. Those are all 1, 2, 3, 4, 5, 6, 7, and etc. Our next big circle is whole numbers. Whole numbers just adds 0 to natural and counting numbers. Our next circle that takes us there is integers. Integers are just negative numbers. So our examples there show -2, -6. And then our big final circle, which entails all the previous ones, is rational numbers. Rational numbers, as you see, there's the -0.2, then there's 2 3/9, a -5 3/4, and then there was a 4.6 with a line over the 6. The line over the 6 means that 6 is repeating forever. So it's 4.666666 forever. As you may always pause the video, go back if you do not understand something, write down questions that you may have that you will bring to class the next day, and then just continue the video when you are ready. I think we're going to jump into some examples here of what we just went over on some of our definitions. Write each fraction or mixed number as a decimal. So we're going to start off with 5/8. 5/8, 5 over 8. 5 over 8 basically is just a division problem. 5 divided by 8. So if you took old school, you want 8 divided by 5. And 8 does not go into 5, so we put a decimal here. We're going to put in some more zeros. 8 goes into 50 6 times. 8 times 6 is 48. There's 2 remaining. Drop down to 0. 8 goes into 20 2 times. That gives us 16. 4 left. We'll add another 0 there. Drop a 0. 8 goes into 45 times. So 5/8 equals 0.625. That's basically all you're doing is taking the fraction, dividing the numerator by the denominator, and solving. Okay, the next one, it is -1 2/3. That's how that is. This program doesn't let me allow it to put in true fraction form. So first we have to do is we have to take this mixed number and make it an improper fraction. You can remember from last year how to make an improper fraction. You take the denominator, which is the bottom, multiply it times the whole number. So 3 times 1 is 3. Then you add the top is 2. So we have -5/3. Okay, there is our fraction. And now basically we're just going to do what we did on the previous one. We're going to take we're just going to take 5 divided by 3. Add some zeros in there. 3 goes into 5 one time. Drop down to 0. We have 20. 3 goes into 20 6 times. Remember, the decimal goes straight up from where it's at. So it's 1.6. So 3 times 6 is 18. 20 minus 18 is 2. And drop down to 0. And once again, we have our 20. So it'd be a 6 again. We'd have 18. And as you see, we're going to have repeating. So we just put a line over that then. So -1 2/3 is -1.6 repeating. Okay, moving on to our next one. 3/4. Once again, we have a fraction. 3/4. We're going to divide 4 into 3. And what I want you to do is do that on your own. We'll bring that into class tomorrow, and we'll check to see if you have some understanding of that, as well as our last one. This is 3 1/11. You just got to make that mixed number into an improper fraction, and then divide to get your decimal. Okay, let's take a peek at our bottom ones. We're going to write as a fraction or a mixed number and put into simplest form. So what they gave us is 0.45. We have to write that as a fraction. So what we're going to need to do is look at our placements. Remember, the first part to the right of the decimal is the tens. The second spot is the hundreds. So when we write a fraction, we always use the last digit spot. That's the hundred, so 100 is going to be on our bottom. And then we just write the number as is, so we have 45. We have 45 over 100. And it says simplest form, so we have to simplify. So we have to knock it down. What do they have in common? If you look, there's a 5 and a 0, so there's probably a 5 in common. So let's just divide each side, top and the bottom, by 5. 45 divided by 5 is 9. 100 divided by 5 is 20. And right there is our simplest form, 9/20. You can't simplify that any. Okay, now we're going to look at 0.32. Once again, you're going to look at your farthest number out. It's in the, once again, that's the tens, that's the hundreds. Hundreds is your simplest form, or hundreds is your denominator. Take the 32, put it on top. Now, do the top and bottom have a common denominator? Yes, they do. They're at least even numbers. Look at the last digit. If the last 2 digits are even, they have 2 in common. So we can divide top and bottom by 2. 32 divided by 2 is 16. That is 50. And simplest form, 6. Look at the last digit. 6 is even. 0 is even, so let's break it down some more. 16 divided by 2 is 8. 25ths. And right there, I believe, is your simplest form. You're going to break it down. Okay, I'd like you to try your last 2. See if you can write them as there and bring them into class. We'll go over that first thing in class. See if you can understand the last 2. And our last slide is our real-world example. Each lesson we do have at least one real-world example problem that we'd like you to try to solve or work together on solving, and then you'll have some real world examples in your classwork. So in our real world example, this one, in a recent season, St. Louis Cardinals first baseman Albert Pujols had 175 hits and 530 at bats. The nearest thousandth, find his batting average. Okay. What we're going to do here is we're going to make a ratio. Remember, you have parts over whole. And when doing this, the whole is the total, or he had 530, so 530 will go on the bottom. Parts is he had 175 hits. So 175 over 530. And what we're going to do is you divide that, 175 divided by 530. If you have a calculator, you can punch that in. And what you get in the calculator, you get 0.33088679. Now let's look back at our question. Our question is the nearest thousandth, find his batting average. So once again, we have to know our placements, see which one thousandth is. We have our tens, hundreds, thousands, 10,000. So there's the spot we're looking for. Now we can look back at it to see if this is 5 or higher. If it's 5 or higher, it rounds up. If not, it stays the same, and it's a 1. So Albert Pujols' batting average is 330. Okay, any questions, please write them down or review the tape, and we will go over this in class.